Hey guys, welcome back to the shop. I've got the VM getting warmed up behind me, and I'm getting ready to start what I hope is going to be the final setup and the final machining segments for this adapter plate that we're machining. Just do a quick recap. We're helping out our friend Tim, the motorcycle mechanic, where he is wanting to convert the original chain drive system on his panhead Harley Davidson to a more modern flat belt pulley, okay? And we've already got this pulley machine. We've got videos on that on the channel. And we've already started working on the adapter plate here. You may have seen that, but we need to finish the outside. But just a quick recap, we're machining an adapter plate that's going to be bolted to this pulley right here, which will also be fastened to the original brake drum there, which will allow him to run a flat belt system on his Harley Davidson. So we've already got the inside machined. This is our stock here. And what we need to do is finish the outside. Basically what we have left to do is just machine this outside area off of the stock and then put a radius on both top and the bottom. So we've got our adapter plate machined right here. Got videos on that. And we're gonna start getting this guy set up in the milling machine and hopefully get started on this. It's a pretty simple operation. We're gonna use 3 end mills total to get this job done, and just rough that outside out and then finish it, and then use a bullnose mill to machine the corner radius that we need. The corner radius is so that whenever this is installed in the pulley right here, we've got a radius in this corner, and we just want to match that up and make sure that it fits flat and pulls up against this face right there. So I am ready to get started on it, and I'm excited to see this completed. So let's jump right into it and get going. Quick recap on what we're going to be doing on our setup. This is our adapter plate we machined, and we're going to take our workpiece. Once this is bolted down, this will just be bolted down like this onto the fixture plate, and then we'll take our workpiece. All right, get it mounted on here. We've got 832 bolts we'll use to bolt it down through these 3/16 holes here. Once everything is aligned in the center where it needs to be, our work offsets, we'll use a chip splitter end mill and just rough all this outside off of here completely. We're going to use a finishing mill to make a finish pass across there, and then the bullnose end mill is going to cut this top radius there. And then once that's done, we'll be able to unbolt it, flip it over at that point, and this material will be machined away. I can't fit it on there because the stock is in the way now, but we'll be able to just flip this upside down, bolt it back down there, make sure our work offset is adjusted accordingly. And then one final operation is going to be machining the radius on this top outside corner there as well. All right, so we'll head over to the VM and start getting everything set up. All right, that looks good. We're using those low profile bolts there. So next up, we'll get our probe, find the center of this hole, and that'll be our XY0 for our work offset. We're going to probe this face here. This is going to be our work origin for Z0. So we'll just do a single surface Z here for G54. So since we technically have 2 of these work pieces, I'm going to start with the first one here. This is the one that I had trouble with, and it's actually got a helicoil in that hole there. So this one is my personal sample now. And we'll use this as our test subject, make sure everything is good, and then once we have it proven on this piece, then we can certainly move on to the second work piece. I'll give you a preview of the program here. I did design this in Fusion. This is not conversational. So we did a post-process and put it in the computer here. All right, and what we'll start with is the half-inch chip splitter and using a 2D adaptive, and that's just gonna go around the outside and just rough all that out with an even step over. I've got it set to 150 thousandths step over. And we'll see if it'll handle that. It should handle it just fine, but I'll control the feed knob here if it sort of overloads it a bit. All right, there it is all roughed out. Then we're gonna come in with a 2D contour just to clean up that outside, but it's gonna leave that 2 thousandths large. And then we'll come in with a bullnose end mill, 60 thou corner radius, and it's gonna machine that 1/8 radius on this side right there. And the reason I'm leaving 2 thousandths on this OD is that I want to mic it and see where it finishes at. And then I have one more 2D contour pass that'll come back and clean that last 2 thousandths up. I'd like to get it a very, very close fit on that pulley. So before we take those final 2 thousandths off, that'll give me a chance to measure it and see where it's at and make some adjustments accordingly if we need to. So it's just finishing up that top corner radius right there, using the flow toolpath in Fusion to get that done. All right, and then once this is all completed right here, then we'll flip this upside down from where it's at, reprobe it again, and then that flow toolpath we'll duplicate that again on the opposite side to cut that 1/8 radius on there. All right, I think we're ready. I'm gonna go ahead and prove it over here in my machine and make sure we're in the right position, and then from there we'll start making some chips. Okay, I've done some checks and everything appears to be correct, so we're gonna go ahead and start making chips now. And as I usually do, whenever the tools come down, I'm gonna slow or wrap it down just to be sure that we're not crashing into the workpiece or down here into the table. And then once we have that height verified, we'll go ahead and start increasing our feed rate. I'll probably start at about 50% because we do have a pretty aggressive feed rate on the adaptive, taking that off, and I want to make sure that we don't overload the cutter or the machine, and we'll just gradually increase it as we need to and get that cut. So let's go ahead and get started on it, all right? I apologize about the coolant, but we're gonna have to run it here, and I'm gonna do the best I can to give you the best shots that I can. All right, here we go. That's 50% right there. It's at about a 40% load. That's 60%, 50% load. Okay, I think that went pretty well. By the way, I ended up going up to 80% on our feed rate there, and I felt like it was doing just fine. All right, so now we're gonna go ahead and continue on. I got the optional stop engaged here, which I'm gonna turn off now. This is just a cleanup pass, really. I think it's taken about 18 thousandths off of the OD there. Now we're going with our bullnose end mill. That looks good. Yep. All right, so this is just cutting that 1/8 radius on that top corner there using the Flow toolpath infusion. All right, that was me halting the program because this is where I wanted to stop and actually measure this this part. I'm going to go ahead and give it a look and an inspection. Radius looks really nice on there. I like it. So I'll get the micrometer and we'll give this a measure and see where we're at. All right, we've got our 10 to 11 mic here, and I just checked it against the 11-inch standard, and it looked like it was within 1/10 of being perfect. So we're just going to go with that. That's feeling good right about there. All right, and we're getting 10.860. That is good. That is good because I left for our finish pass, I left 2 thousandths per side, so 4 thousandths total, and our target is 10.856. So right now we're at 10.860. That's 4 thousandths off of our target size. So I mean, it's cutting right on the money of where it needs to be. Very good. All right, so I'm going to continue on and let it make that final contour pass and see if it takes that 4 thousandths off the diameter there, and hopefully land right on the size that we're shooting for, 10.856. All right, that was our rapid. Here's our feed. Okay, I'm going to turn the coolant on. That's it, end of program. Total cut time was just under 13 minutes for all of that, and that's with me slowing everything down. I'll get our micrometer and go ahead and give it another measure, see where we landed. That's feeling good right there. And it looks like we're at 10.856 and 4/10. This mic does not have a tenths graduation on it, so I'm having a guess there. But it's not quite halfway between the 6 and the 7, so I'm just going to say 4/10. And I think that is actually going to be right where we would like it to be. I'm coming over looking at my print. I've got the bore on the sprocket measuring 10.8568. So with that being 4/10, it's basically giving us 4/10 clearance between this adapter and fitting down into the sprocket. So let's just call it a 1/2 thousandths. And I think that's beautiful right there where it's at. I'm happy with it, and we're gonna call this operation done. Last thing we'll have to do is flip it upside down, reprobe the top of it, and just cut the same radius on the top of it there as well. So I'm gonna go ahead and get all this cleaned up, and we'll take this one off. We're gonna put our final workpiece on here and repeat all this and get it down to this stage before we flip it over. I wanted to just kind of verify this and see if my measurements are telling me correctly. And it's such a close fit, which is what Tim wanted anyway. He didn't want it loose. I can tell that it's trying to, I just can't quite get it squared up because it's got to be perfect for it to go down in there. But I think that's going to give him the fit that he's actually wanting to get it. I can tell that it's trying to go, but I don't want to get it stuck. But I think we did good on this. Okay, workpiece number 2 loaded up. We're ready to hit cycle start. All right, this went well, and we finally got an actual time, and it's 10 minutes and 7 seconds is what it took to machine what you saw there. I'm gonna go ahead and give this a measure and see where we landed. See if we're matching the first one there. It's nearly identical. 10.856, and that looks like 4/10, just like the first one there. I'm happy with it, real happy with that. And it's making me feel good that we are approaching the finish line now. Okay, now we can go ahead and flip this guy over, get it reprobed to make sure that we're on our proper Z-plane. And then all we got to do is just make one pass around this the bottom corner here that's going to match this radius on this side. While we're taking this apart, this might be a good time to mention this. I haven't really discussed it. I don't think I discussed it, but I'm probably got some folks wondering why I just didn't do this in the lathe, you know, the manual lathe. And that was the original approach that I was planning on doing. When I first took the job, I was thinking in my head, well, we'll just go to the lathe, and you know, this is lathe work. But the more time passed and the more I'm thinking about it and the more practice I'm getting over here trying to learn these CNC mills, the more that I realized that I wanted to use the abilities that these machines will give me. And this right here is why I decided to go this route. This is not causing any kind of distorting on the workpiece like a chuck will. I got to thinking that, you know, once I'm chucked on this piece in the forge jaw, getting everything trued up, it's most likely going to squeeze it in some way or the other. You know, even a thou or two is going to throw it off. So I thought that bolting it down this way would not put any stresses on the diameters of the part there and cause distortion. So when you unchuck it, you know, you end up with something that's not round but a little bit more elliptical. And so that is the reason why I decided to go with the mill. I wouldn't have to worry about squeezing it. Now, you could very well take this fixture that we machined here, we machined that in the lathe, and bolt this to it and do it in the lathe there as well. We could definitely do that, but I just said, no, if we're going to go to the mill, I'm just going to do this job in the mill, utilize my Milltronics that I have invested in, and watch the machine do a beautiful job machining this part. So that's the reason why we've gone the route that we have. But we could very well take it out now and go to the lathe and machine this other corner out, but I've already got it set up. I just want to complete the job at the machine that I'm using right now, and that's what we're going to do. All right, so I'm going to go ahead and take this one off. Go ahead and clean our fixture plate here, make sure we don't have any chips that fell down on it, and let's see if it'll fit the other way. No, that is not going to work because I did not take in consideration the depth here. So I was looking at this wrong. So I'm going to have to modify the fixture in order to get this last radius on there, which is fine. I didn't. So this is another mistake that I made. I wasn't thinking about it in the correct way, that we wouldn't have material coming all the way through here before touching this face right here. So that's fine. So I may be going back on what I just got through talking to you guys about. We may just go ahead and bolt it back down just the way we had it this other way, and then just simply go to our lathe and a 3-jaw chuck and come in here with a tool and just tool that radius. That might be what we do, just to simplify it and get it done. Although I was hoping that it was going to be simple to just do it this way. So either way, something's got to be modified. Something's got to be modified in order to run it. So that OD needs to be turned down further, a smaller diameter, so that it could slide down and fit that register there. All right, so I'll back up and figure out which approach we're going to take. I've got our manual chucked up in the forge all indicated, and I'm just going to go ahead and relieve this material here so that our workpiece can fit down on there properly. We want to take it down to 9 3/8 or about 9.370 to give it a little clearance. Got about 30 thousandths to come off of that. All right, that should clear. I'm gonna go ahead and cut some chamfers on that, and then I'll test fit it. All right, we'll give it a test fit here. This is clearance. This is all clearance, so it should still be sitting on this original register that we machined in there the first time. If I can get it straight, there we go. All right, that's on there, so it's sitting on that register fit. And I think what we can do, since we're all set up here in the lathe, we can take this, this is a corner round end mill right here. And so it's got a proper grind on there. We can put this in our tool post and come in here and use this form tool to cut that radius. And by the way, I've been calling out the incorrect radius. This is, this was machined for a 1/16 radius, not a 1/8 radius. It was originally going to be 1/8 radius, but we changed it to a 1/16. And I've just been saying the wrong thing, but it is a 1/16, and that's what this cutter is right here. This is one of my dad's old do-all cutters. All right, so we'll go ahead and get this bolted up here and see if we can get this last operation finished. There's our tool set up. I'm using a little collet chuck, a little ER25 collet chuck, and a bore and bar holder. And then we've got our corner rounding end mill clamped in there. I've got it leveled out, centered. I got it ready to go. We've got everything touched off, and I'm making use of the DRO for this to get it done. So we'll set up a little camera so you can get a good shot of this, and we'll go ahead and get this cut. Remember, just because of the way this cutter is positioned, we are going to be running in the reverse direction on the spindle. Almost there. We need a little bit more. I'm going to call this one done. This radius is matched in there really nicely. The tool did a good job, and I'm gonna consider this one done. I was trying to get you a different angle and a better shot with my other camera, but for some reason today, it just didn't want to focus. It was jumping between the regular lens and the macro lens back and forth before I even started to cut. So I had to set it up where it stayed and got you some kind of shot. So hopefully that one turned out right. But anyway, I'm going to take this one off and we're going to put our second workpiece in there, and then we'll get that one cut too. Well, I believe that's going to be all the machining right there. I'm real happy with the way this radius looks. It's blended in there nicely. It looks good. So really the only thing I got left to do is just to get this out of the lathe, and I've got a lot of tools and cleanup and stuff to do. I still got to get the mill cleaned up, but I believe we're pretty well done. So I'm going to work on getting this out and getting some stuff cleaned up, and then we'll come back with some final words and kind of show you how everything is going to fit together. Well, I'm happy to say that we have reached the end of this project and this job. And I'm happy to see the end come to this job. It has troubled us more than one time. We've had several incidences that has come up during the machining and during the setups that has kind of given me some trouble. But we were able to push through that and succeed, and we now have a successful part. Well, actually, this one's going to be mine for my little display table in there in the office, but this one is the one that Tim is going to take with him, that he is going to put on his motorcycle here. I'm happy with the results. We machined it exactly to his specifications. He did such a good job on the design and creating those hand-drawn drawings of the part that we converted over to Fusion and built a file in Fusion to kind of help us out. But it turned out exactly the way that he was wanting to, and I hope that he enjoys it once he gets it in his hand, and it all goes together just as planned, and it goes on to the bike. But it's been a little bit more time consuming than I expected it to when we first talked about it. When he came to me and brought the parts and the prints and we talked about it. Jobs like this are oftentimes very difficult to give an exact price on. When you have something totally custom like this, you know, you got to modify this part right here, which we did. You know, you got to make this. We had fixtures that we had to machine. You've got design time in there on the computer. And then, you know, you run into troubles like I did. It's just really hard to determine exactly how much time that you're going to have into custom jobs like this. And that's where it can be a little concerning as well, because, you know, you want to treat everybody as fairly as possible. And that's my goal, is to always try to be as fair as I can. But it's just difficult knowing how much time you're going to have in it. And oftentimes you end up spending way more time than what you originally thought. But Tim was fine with that since the get-go. He knew that there wasn't just, you can't just say it's going to be X amount of time to get this done. It's going to cost this much money. The job is going to cost this much to get it done. It wasn't that way. We just went ahead and started on it. And along the way, I communicated with him. He'd come by and he would see me and we'd catch up and he'd see where I was at on the job. And I just wanted to make sure, like, this is how much time we got in it. I still have this to do as well. And he was fine with that and wanted me to get it all done. So I appreciate him working with me on this job. And it's always a pleasure talking with Tim and dealing with him and listening to him, you know, talk his mechanics experience there as well. But back to the part here, we do have a successful part, and I'm not going to be able to put this together because we have such a close precision fit on this pulley. But what I will do is just kind of give you a quick little rundown of how this is going to go together. So we have our flat belt pulley here that we modified. You can see our spot facing that we did on this side. These are the bolts that he's going to be using to secure it all together. These are stainless steel bolts, and they're going to fit in there just like that right there. And then the back side of that bolt here is going to be threading into this side of the adapter plate, just like that. So these two get bolted together just like that with all of these bolts that's going to be going through the pulley. All right. Now you also have the brake drum right here. So this is the brake drum, and our adapter plate that we machined is going to fit on here just like this. You have that flange. That's where the sprocket was originally mounted to this. And then you have a very particular hole pattern in this. You have the 1, 2, 3, 1, 2, 3. So you got to line up those with the 1, 2, 3 hole patterns there. And then you've also got, we've got 4 holes drilled and ringed for 1/4 inch dowel pins. Same way over here. So those 4 dowel pins are going to line up with those 4 holes into the pulley there as well. But if we take this and drop it down onto the drum here, I'm just going to try to get those holes lined up. Just as it gets up to that flange, it gets a little bit snug on there. Just like that, right there. That looks pretty good. And then he's got rivets that he's going to be using to hold this together. It's these guys that look like that, little domed head rivets. And these will be going through. I didn't get it lined up very, very good. Let me try that again. Like that. So there's one on the back side. I don't know exactly how these get installed. I've never used these before. But something like that. You got one that goes from both sides and they get peened together. But there's another rivet right there. So that's how the adapter plate gets secured to the brake drum. And then once all those are together, then you can take your brake drum and your adapter plate. This is the only way you can hold it, is pick it up in the middle. And then this is all going to fit together just like that with those 4 dowel pins. It's going to get bumped down in there. And then the bolts come through the other side and hold all that together. With any luck, it should all fit, right? So by the time you guys are seeing this video, I highly doubt that Tim's going to be in a place where this is going to be together. But if it is, I'll ask him if he'll send me some photos so I can show it on video. But I don't think that you guys will see that by the time you see this video. It's probably going to take him a little more time to get to this project if I had to guess. But whenever he does get it all together, I'll ask him to shoot me some pictures and send me some photos so that I can share that with you later on. Maybe we can just touch on it and give you guys an update on where we are on this project. So I think that kind of covers everything right there. So I think we're all wrapped up here, and I'm ready to sign off, and I want to go get everything cleaned and get all my tools picked up and let him know that we're finally completed with his project here. But I am happy with the way it turned out. It looks good. And I did have fun machining this as well. We had some troubling moments, but we also had a lot of good moments. And every time you take a part and you successfully get it machined and you're finished with it, it brings a smile to you. And it's just makes you feel really good that you get to do this kind of work for a living. I'm certainly happy that I do. So that's it, guys. I'm going to sign off. I hope you guys have enjoyed this project. I hope you've enjoyed all of the videos. I know it's been several, more than I expected it to be, but we've had a lot of fun. We've got to play on our manual machines, the lathe, the KBC mill, and the Milltronics, the VM. We had a lot of fun using that and helping us get this done. So again, I hope you enjoyed all the videos, and I hope you come back and watch the next project, all right? So we'll see you then. All right, I know I said that was the end of the video, and this is the end of the video, but I spent a little more time trying to get all of the parts bumped together so that I could prove to myself that everything was fitting like it is, and we got it. So both the brake drum and the pulley have a very slight bump fit. You can get them to go together, you know, and I didn't want to force everything, but if you take a soft blow and tap on it and get it perfectly aligned, the two parts would start going together without a bunch of force. And it took me a few tries to actually get the holes aligned to where I could get everything to screw together. But we do have all of the stainless steel bolts installed there. I think you guys might be able to see that. Those are all tightened up in there. Now I don't have the rivets in there because on this last try, I had, on the previous tries, I had the rivets lined up. And on this last try, I finally got the 1/4 inch bolts lined up, but then I was off just a little bit, just clocked slightly, you know, maybe 5 thousandths, and I can't get the rivets to slide all the way through there. But they are aligned and all the rivets will go in there. But this is a really tricky thing. Like once this thing goes together, it's gonna take a little bit of effort on Tim's part to get this perfectly aligned and get it together. So it's a little challenging to get it together, but once it is, it's there forever and you should never have to take it apart again. But anyways, I just wanted to give you one last update on what the pulley, what everything looks like, final fit, you know, everything put together and what it's gonna look like, minus the rivets, of course. So that made me feel a whole lot better seeing it completed like this before I ended the video and before I actually give it to Tim. So anyway, this makes me happy and I think it turned out nice. Everything is so close that everything it should be running perfectly true together. So now this is officially the end of the video. See you guys later.